Okay, scholars, so here is 6.1. We are using mapping diagrams to represent functions. Functions. All right, I'm going to underline this. I'm going to star it. I'm going to smiley it. Chapter 6 is all about functions, and we're going to be putting the funky back in functions. All right. So we're looking at these things called mapping diagrams. Here's an example, and here is how this works. We're going to practice a little bit ourselves here by making our own little mapping diagram. So let's go ahead and do one of those, and feel free to pause at any time if I'm moving too fast so that you can re-watch or just copy down and get caught up. So we got our inputs, we got our outputs. I'm going to put in, I'm going to put out. All right, now I think it's helpful to think about function as a machine where you put in these inputs, which is also our x values, and we get out something new called y values. So here's an example. Let's pretend that we're going to put into our function machine, let's put in, how about 1, 2, and 3. Now these don't have to be in order. They could have been in random orders. They don't even have to be numbers. I could have put anything into my function. But I put a 1 into my function, goes in, the machine, the function machine does its funky thing here, and then output something else. So I put in my 1, and out, let's say, comes a 3. In goes 1, out comes a 3. Okay, now let's stick a 2 in that function. Let's stick a 2 inside of my function, boom, 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 and outputs a 4. Now let's put a 3 into my function. 3 goes in, boom, 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 boom. Out comes a 5. And that's how a function works, all right? Now, a rule that we could come up with then, and this is going to be more the next section, but a rule that we could come up with is we could say that's, well, from 1 to 3, we went up 2. From 2 to 4, we went up 2. From 3 to 5, we went up 2. So a rule could be, you could say plus 2, or you could write an equation that says y equals x plus 2, because the output is equal to whatever the input is, plus 2, all right? Okay, so then determine whether or not these are functions. Now here's the important part about a function. Every output can only have exactly one input. So, is this a function? Well, that's one input goes to one output. That's a big fat yes. One input goes to one output. This one here, this input goes to one output, it's good. This input goes to 2 different outputs. Ooh, that right there is a sad face. That is not a function. Every input can only go to one output. Let's put a no there, okay? Now, pause real quick. Pause your video. Pause, and I want you to try these before you start again. Okay, hopefully you paused and you tried. These should have been, this is a yes, this is a function. And why? Every input only goes to one output. Now, this example is interesting. These inputs go to the same output. That's okay. That's okay if that happens. What can't happen is if one of these inputs were to split off and go to 2 different outputs. That's when it would be broken. And this is a no. This is a no because of this 0 input goes to 2 outputs. Okay. And then, okay, good. This is good. One other thing that could happen on your practice page is you could be asked to list the ordered pairs for a function. So real quickly, I should note that your inputs are like your x's, and your outputs are like your y's. And if I was writing this function as ordered pairs, I could say that this is the point 1, 3. I could say that this is the point x2, y 6. This is the point 3, x, y 9. Okay, so that could be on your practice page. I wanted to show you, and that's just x comma y. All right. Okay. All right, scholars, in this last bit here, you know, these points are a little bit off and it makes it weird. Let's fix that. So let's make these points extra bold. And I'm kind of gonna like slide them a little bit to the left here. It's gonna make this problem make a lot more sense if we can actually see where these points are. All right. So this is a function represented as a graph, but we can also represent it as a mapping diagram just by remembering that the inputs are my x values. So I'm going to put x, maybe in quotes I'll put input, and the output are my y values. So I have y values and output. So this point here has an x value of negative, label those axes, negative 1, 2, 3, 4. So I'm going to put negative 4. And that outputs to this y value, which would be also negative 4, negative 1, 2, 3, 4. All right. This x value is negative 1, 2, 3. And it outputs to its y value, which is, on the y-axis, down 1, 2, negative 2. All right, and then this would be negative 2, and so on and so forth. I'll let you finish that up on your own. Writing an equation to represent the function, well, this is just straight up ghost of 8th grade math. I told y'all that it wasn't going away, and it doesn't. That's a line. It's a linear equation. I'll make it an angry ghost. It's a linear equation. That's all it is. I can write this linear equation to represent the function. The m, or the slope, would be rise over run. Well, in this case, that's up 1, 2 over 1. That's a slope of 2. The b value, where it hits the y-axis, that y-intercept is 4. b is 4. So then my equation, y equals mx plus b. M is 2x plus b. b is 4. There's my equation. All right, that's putting the fun back in functions, y'all.